Hi, I'll be performing exploratory data analysis on terrorism dataset using Python. First, I have imported some libraries such as pandas, matplotlib, and cmon. Then I imported the data inside Python and stored it inside DS. Let's see how this terrorism dataset looks like. So as you can see, this is our data. This data consists of 135 columns and 1,81,000 rows. This many of which these columns are NaN values, and performing exploratory data analysis on so many columns is really hard. So what we can do is actually take a subset of these columns. The subset can depend on what kind of application you're working for. But in my case, I've taken some of the some columns which I deem to be useful. So I've taken some columns such as country, year of the attack, etc. So let's run this. The subset of this data will consist of many NaN values. So let's drop all the rows which has NaN values. So this is how our data will look like. We'll be performing our exploratory analysis on this data. Uh, Now let's check for any duplicates, whether any duplicates exist in our dataset. It looks like there are many duplicates. So since these all duplicates are useless and not good for our analysis, so let's remove them. As you can see, this shows that our all duplicates are removed, which is a good thing. Now let's see any other sort of data cleaning which is necessary. In this case, I found one feature, one column called ransom, which shows whether the ransom has been taken in an attack or not. So 0 represents no ransom, 1 represents there was a ransom. But I think there is no meaning for -9. So let's remove all the columns which has -9 in it. So we have so yeah, as you can see here, there's no -9 left, which means that all the -9 ransom, which is invalid data, has been removed. Now it's time. Now we have done all the data cleaning process. Now it's time to ask a few questions about the data or start the exploratory analysis. First, we'll start by seeing the attack frequency versus the years. So I'm plotting this data using Cmon histogram plot. As you can see here, the attacks gradually rise between 1917 to 1919, peak between 1919 to 2000, and decrease. Then again gradually increases till 2010, and suddenly there's exponential rise after 2000. So for simplicity's sake, let's break this data into two parts, like one before 2000 and one after 2000. Before that, let's see what are the successful attacks. How many successful attacks were actually done. So this is our successful attack distribution. It looks quite similar to total attacks. Uh, let's see what attack type did terrorists use the most. So as you can see, there's bombing, armed assault, explosion, and these are the frequencies of those occurrence. Bombing and explosion has the most frequency of occurrence. That doesn't mean that it's the most successful type of attack. Uh, we can, if we divide the successful attacks divided by the total number of attacks, we can actually find the percentage of successful attacks. So in this case, the bombing, which has the highest frequency, has now only 75% success rate. The highest success rate of an attack is 98, which is hostage taking. We have facility slash infrastructure attack at 90%, and so on. So let's see which countries had highest attack success rate. Afghanistan had the highest uh, had success rate of 84%. Like that, Albania 76, Algeria 88, as you can see. Let's see the unsuccessful attack distribution. I'm filtering this data using query command and setting success. Success is the column name as equal to 0. So this will filter all the values if all the rows if the success value is 0. So let's run this. This distribution is also similar to the previous one of the success distribution. Uh, let's see the most failure attack type. So assassination has a highest failure chance. Armed assault is at 9%, and so on. Similarly, this is the failure percentage of countries. Now let's look at major terrorist targets. So as you can see here, uh, I've filtered this data into two parts. One is before 2000 and one is after 2000. But because as you can see, there is a huge difference in the distribution here. There's one peak here, a small peak here, and there's a bigger peak after that. So arbitrarily, I'm choosing 2000, year 2000. So in this case, I've chosen all the targets before 2000 by using this query command. I filtered everything, and I've taken all the target types and divided by the total number of target types. So, in other words, um private targets of private citizens and properties only 16%, which is the highest. Then comes the government, which is the second highest target for terrorists. Business is the third highest. Police is the fourth. Military is the fifth, and so on. And so this was before 2000s. Now, what about the target types after 2000? So let's run this. As you can see, the 19% of the targets after 2000 is still private citizens and property. Government again stands at second. Uh, the third target type before 2000 was business, and now it has become police, military. Business has gone to the fifth position. Uh, yeah. So this is for the exploratory data analytics.